Hi guys, this is Ashish Manglani and today I'll be discussing the solutions to the Codeforces round 828. So let's begin with problem A. So in this problem you are given an array of integers which is being transformed into an array of lowercase English letters. So in one operation you can select any number x from the array, and for all the occurrences of x you replace it by letter y that you can select. So at the end, you want to transform this array E into the given string S, and you have to determine whether it is possible or not. So like we have been given array A and we want to transform into array S. So let's say this is array A and this is array S. So what we do is we start iterating from index 0 to the last index of my array A, and I see whether this number has already been mapped to some character or not. So if this number has not been mapped to any character till now, what I can do is I can map this number to the corresponding character that is present in my string S. And if this character has already been, like if this number has already been mapped to some character C, then what I do is I check whether this character C is equal to my S of I or not. Because if this character C is equal to my S of I, then the mapping till now is valid. Otherwise the mapping is not valid, because at the previous stage I said that my number 5, let's say my number 5 was mapped to some character C, and after that I'm saying that my number 5 is has to be mapped with character D. So this mapping is not valid. So I just have to check whether there exists a valid mapping or not. So how do I implement this? So this is my implementation. I take the input array, I take the input string, and I start iterating from the 0th index to the n minus 1th index, and I check whether the corresponding integer has already been mapped to some character or not. And if it has not been mapped, I map it to the corresponding character of my string S. And if it has been already mapped, I check whether the corresponding mapping is equal to the ith character of my string. And if it is not equal to the ith character, then the mapping is not valid. So I return no. Otherwise, I return yes at the end. So this is the solution for problem A. And so let's move on to problem B. So in problem B, you are given an array of n integers, and you have been given two type of queries. So query one says that add x to, like you have been given an integer x in the query, and query one says that add x to all the even elements of the array A. And query 2 says that add x to all the odd elements of the array A. And after processing each query, you have to find the sum of the elements that are present in the array. So basically, just a second. So you have been given array A, and let's say it contains some x number of even elements and y number of odd elements. So after like each query, uh, let's say my query is of type 1 that says that add a number, like let me call it, sorry. So let me call the number of odd elements as O and the number of even elements as E. So, and the query is of type 1 that says add X to all the even elements. So what you can do is you can not manually add, like you cannot just iterate through all the even elements and add the number X. So what you can do is you can store the initial sum, like the initial sum of the elements that are present in the array, and for each of the even element, since you are adding number x that is same, so what you can do is just increment the sum by the count of even elements into x. So since for each of the element you are incrementing it by x, so you increment your sum by the count of even elements into x. And similarly for a query of type 2, what you do is you increment the count, like you increment the sum by odd into e, where odd is the number of odd numbers that are present in the array right now. So and the transition is like suppose your query is of type 1 and it says that add x to all the odd numbers that are like add x to all the even numbers that are present in the array. So if x is also even, then the even numbers would still remain even after performing the operation. And if x is odd, then all the even numbers after adding x to it will get transformed into an odd number. So after performing this operation, the count of even numbers would get reduced to 0, and the count of odd numbers will increase to n. So this is what the solution is. And similarly for the odd query, like add x to, so let me explain this. So if you have been given a query of type 2 which says that add x to all the odd elements of the array, so if x is even, then the odd numbers would still remain odd and the count of them would remain the same. Otherwise, if x is odd, then the odd, like after adding x to all the odd numbers, those odd numbers will change to an even number and the count of odd numbers will become 0 and the count of even numbers would become n. So this is the solution. So how do I implement this? So initially I store, like I take the input, I take the number of queries, I take the current array and I store the current sum, and for each of the odd elements I increment my CNT1 by 1, and for all the even elements I increment my CNT2 by 1. And to process all the queries, I check whether my query is of type 1. So if my query is of type 1, I have to increment the, like, just a second. So for the query of type 1, like I have to increment all the odd elements by a. So I check whether this x is also even. So if my x is even, so the count of odd numbers would remain the same. So my sum would just be incremented by x into the count of odd numbers. Otherwise, my sum would be incremented by x into the count of odd numbers. But after performing the operation, the count of odd numbers will become 0 because all the odd numbers will get transformed to even numbers and my count of even numbers would become n. Similarly, for the query of type 2. So this is how I implement this problem B. So let's move on to problem C. So in this problem, you're given a string that describes the state of a traffic light. So what it is, like, let's say the traffic light is at, like, the traffic light shows R at the current position. So after 1 second, it will show green, and after 1 second, it will show green again, and after 1 second, it will show R, and then it will show Y, and so on. So this is a cyclic pattern that the traffic light follows, and you have been given the current color that the traffic light is showing, and you have to find the maximum, like the possible time that it can take for the traffic light to turn green. So basically, just a second. So you have been given this pattern of traffic light that contains the characters R, Y, and Z. So red, yellow, and green. Red, yellow, and green. So you can move past the road only if the traffic light is green, and you have been given this cyclic pattern that the traffic light follows, and you have been given the current color that the traffic light shows, and you have to find the maximum possible time that you have to wait before crossing the road. So basically you know what the current character is, but you don't know, like, what state of the pattern the traffic light is currently at. So for example, let's see the test set 1. So the test set 1 is RGG R into Y. So you have been given RGG RY, and you have been told that the current color that the traffic light shows is red. So it can be either this index or it can be either this index. And if you say that it is index 0, then the maximum possible time you have to wait is 1 second, because after 1 second the color will get changed to green. And if it is at index 3, then you have to wait 3 seconds, because, and this is a cyclic pattern. So like after 1 second it will turn to yellow, after 1 second it will turn to red, and after another 1 second it will turn to green. So if the index is this, then it will take 3 seconds, and if the index is 0, it will take you 1 second. So, and you have to find the maximum of them. So the answer is 3 seconds for this case. So what you do is basically like what you have to do is basically for each of the index that has the character that you are given, like let's say the traffic light shows R. So for all the possible states that the traffic light can be, like let's say it can be at index 0 or it can be at index 3, you want to find the time that it takes to transition to green. So basically you have to find the next occurrence of you have to find the next occurrence of green color that is present in the string. So, and you have to take the maximum of all the possible answers. So how do I implement this? So this is basically an implementation based question. So what I do is since the pattern is cyclic, so to remove the cyclicity, I add I do this s plus equal to s. So since the pattern is cyclic and the first character follows after the last character, so to implement this, I just append my given string to the end of the given string. So I do s plus equal to s, and I iterate for all the positions of the given character. I create a map of character to position, and for all the corresponding characters, I append the particular position to that map, and then I iterate for that. Then I iterate for all the possible positions that contains the character C. So for each of the possible positions, I want to find how much time would it take to transition it to green. So basically, I have to find the next occurrence of green in my string after the ith occurrence of character C. So basically, I have to find the lower bound of the index of green that is present in my array. So what I do is I find the lower bound of my index green that is present after the index of this cth character, and how much time would it take for this case? It would take the next index of the element green minus the current index that I am, and I update my answer to be answer equal to max of my current answer and the answer that I get by this operation, and finally I print my final answer. So this is the solution for problem C, and let's move on to problem D. So in this problem, we are given an array of positive integers, and what you want to do is make the product of all the numbers in the array divisible by 2 to the power n. And to achieve this, you have some number of operations that you can do. Like you can select any particular index and replace the value of ai by ai times I. And like you can perform this operation only once for a particular index. Like you can perform this operation multiple times for multiple indexes, but for a particular index, you can perform this operation only once. And you have to find the minimum number of steps that it would take you to transform this, to make the product of all the array elements divisible by 2 to the power n. So basically, let's see the solution. So we have been given this integer array a, and initially you find the product of this and you check whether this is divisible by 2 to the power n or not, and if it is not, you have to perform some number of operations, and you want to minimize those number of operations such that the product of the elements that are present in the array is divisible by 2 to the power n. So how do we calculate this? So initially, in the given array, we find the how many like we find the power of 2 that is present in the product of the array elements itself. So basically, let's say the product of my array is p, and I want it to be divisible by 2 to the power n. So this product should contain some power that is greater than or equal to 2 to the power n. So like the prime factorization of this product, like the prime factorization of this product should contain 2 to the power n, in the prime factorization, like any power of 2 to the power n or greater than it. So let's say for example, my n value is 2, let's say my n value is 3. So in that case, the prime factorization should contain at least 2 to the power 3. The prime factorization of my product should contain at least 2 to the power 3 in the prime factorization. So only then it would be divisible by 2 to the power 3. Otherwise, it would not be divisible. So what I want this 2 to the power, at least 2 to the power 3 to be present in the product of my given elements. So what I do, like since I cannot just manually calculate the product of the array, so instead what I do is I calculate what is the power of 2 that is present in the product of the array. So let's say that the first number is x, the second number is y, and the third number is z. So the prime factorization of it contains 2 to the power 1, this contains 2 to the power 3, and this contains 2 to the power 5. Then the prime factorization of x into y into z would contain 2 to the power 1 plus 3 plus 5. So this is actually 5. So the prime factorization, like to count, to just count the power of 2 that is present in the product of the numbers, I can just sum up the power of 2 that are present in my numbers individually, and then I would get the power of 2 that is present in the product itself. And corresponding to that, uh, I have some other operations as well. Like let's say for index I can multiply the corresponding element by I. So just uh, this just this is just equal to like multiplying the product by I. So if I perform this iteration, like if I perform this operation on some array index I, then this just corresponds to like multiplying the overall product by I. So I check, like let me call this initial product. So my initial product contains some number of power of 2, and after performing uh, array operation I, so let's say this I contains 2 to the power x, where x is the maximum power that this ith element contains. So after performing this operation, the power of 2 that will be present in my product itself will become 2 to the power initial plus x. So basically, what I do is for each of the index I from I equal to 1 to n, I calculate how many 2 to the power I can I extract from this number. And I have been given initial number of 2 to the power I that was present in my array itself. And after performing all the operations, I have to check whether this 2 to the power, like 2 to the power some number x, like whatever power is present in the product is greater than equal to n or not. Like this 2 to the power x should be greater than equal to 2 to the power n. So I have to check whether this power is greater than equal to n or not. So since I want to perform this operation minimum number of times, so what I do is basically for each of the elements from 1 to n, I calculate what can be the contribution of this number, like how much 2 to the power I can it contribute to my products, and I choose them greedily. Like I choose the largest value first, and then I choose the second largest value, and so on. And finally, whenever my like sum of powers exceeds my number n, so I stop my operations and I say that my answer is equal to the number of operations that I have performed. And after performing all the operations, I check if my sum is still less than n, then I say it is not possible to transform this array A such that it can be divisible by 2 to the power n. So this is basically what the solution is. So, let's go over the implementation. So I take the input array, and like for each of the element, I find what is the corresponding power of 2 that is present in this element, and I increment my initial power by the corresponding value that I get by this operation. And for each of the value for I equal to 1 to n, I see what is the contribution of performing the ith operation. So while this number is divisible by 2, I divide it by 2, and I increment I increment the counter by 1, indicating how much 2 to the power I can this ith element contribute. And I push this into a vector, and I sort the vector. And what I do is basically I choose it greedily. Like I select the element that contributes most to the power I. So that is, I take the last element of my vector, and I increment my initial by the last element of the vector, and I do this operation until my sum is less than equal to while my sum is less than n, and while I still have my elements that are present in the vector. And finally, I check if my sum is still less than n, then the answer is no. Otherwise, answer is just the number of operations that I performed till now. So this is the solution for problem D. Let's move on to problem E. So in problem E, you are given four positive integers a, b, c, and d, and you have to find any pair of integers x, comma y such that it satisfies the following conditions: x has to be greater than a, x has to be less than equal to c, and y has to be greater than b, and y has to be less than equal to d, and x into y should be divisible by a into b, and you want to find any x comma y that satisfies this constraint. So let's say let's see what we want to achieve. We want to say that x into y should be divisible by a into b. So how do we say that a number is divisible by some other number? So let me say that some number x is divisible by some number y. So this can only be possible when the prime factorization of x contains the power of primes that are greater than or equal to the corresponding power of primes that are present in the prime factorization of by number pi. So for example, let's say my prime factorization of x contains prime 1 to the power n1, prime 2 to the power n2, prime 3 to the power n3, and my prime factorization of y contains prime 1 to the power m1, prime 2 to the power m2, and prime 3 to the power m3. So if I want that my x should be divisible by my y, then this n1 has to be greater than equal to m1, n2 has to be greater than equal to m2, and n3 has to be greater than equal to m3. So this is what I want to achieve. And basically what I do is initially I find the prime factorization of my number a into b, and I start iterating from my array, like since my range of x is given to be x has to be greater than equal to a, like x has to be greater than a, and x has to be less than equal to c. So what I do is I iterate on all the possible x, and I find a corresponding y such that, like I find the minimum y, such that this condition is satisfied. Like for all the power, like for all the primes that are present in the prime factorization, the power of that corresponding prime in my x into y should be greater than equal to my power of primes that is present in the prime factorization of a into b. So let's say that I start iterating for number x in the range, in the given range. So I have this x, and I want to find the minimum y such that this condition is satisfied. Like for each prime, I want my power of prime in x into y to be greater than equal to my power of prime in a into b, So let's say the power of prime in a into b is some number m, and my power of prime in x is n1. Then what I want is just a second. Then what I want is and my power of prime in y is n2. So what I want is n1 plus n2 has to be greater than or equal to m, like for a particular prime I'm talking about. So I want this n1 plus n2 has to be greater than or equal to m. So n2 has to be greater than or equal to m minus n1, So like for each of, like I start iterating for x, like I start iterating on x in the range of a to c, and for each of the prime I calculate what is the minimum power of that prime that should be present in my number y. So I check what is the minimum power of prime that should be present in my number y, and I calculate the product of the corresponding primes. So that will give me my number y, and I check whether my number y is like lies in the given range. So let's say if my given number y lies in the given range, that is from b to d. So if my given number y lies in the given range, then this is possible answer. I can just print out my corresponding answer. Otherwise, what I can do is I can like since I already have the minimum possible y, so if I multiply this y by some number x, like if I multiply this y by some any other number of my choice, let's say c. So if I multiply this y by some constant c, so this will become c into y, and this will still satisfy this constraint, because what I said is my n1 plus n2 has to be greater than or equal to m. Okay, and like this has to be greater than or equal to, and I said that my minimum possible n2 that I calculated was m minus n, So I can increase this n2 by any amount that I like. But I told that this should be minimum m minus n. So what I do is I can multiply this y by any constant. So I check for this product of y, that is like I check for the multiple of y that is just greater than my number p, that is just greater than my number p. And if that multiple is less than equal to t, then I say that this is a valid answer, like x comma y is a valid answer. So this is the solution for it. And how do I implement this? So basically, what I do is I take my input A, B, C, D. This need is the corresponding modulo that I want, like the product of A into B. Then I start iterating on my first number from A plus 1 to less than equal to C. And I like calculate the GCD of my A into B and my number I. Then I divide like then the minimum possible y that I should have is this need divided by GCD. So how do I get this? I'll explain this just a second. So basically I said that the prime factorization of A into B is given to me. The prime factorization of A into B is given to me. I have the prime factorization of my number x, and I want the minimum prime factorization, like this is the prime factorization of my number x, and I want the minimum prime factorization of number y such that the corresponding powers in x into y is greater than equal to my corresponding powers of A into B. So after taking the GCD of them, what I get for each of the prime, I'll get the minimum of the power that is present in my A into B and that is present in my number x. So let's say like the prime factorization of A into B is p1 to the power n1, and this is p2 to the power n2 and p3 to the power n3, and my GCD is p1 into minimum of n1 comma m1 n1 comma m1, where m1 is the where the prime factorization of x is p1 to the power m1, p2 to the power m2, and p3 to the power m3, p3 to the power m3. So I get this p2 minimum of n2 comma m2, minimum of p3 into minimum of n3 comma m3. So this is my given x into y, and this is the GCD of it. So what I do is if I divide this by, if I divide my corresponding A into B by the GCD of A into B and x, what I get is the minimum possible power that should be present in my this y. So basically this is just the implementation of this equation that I showed you, like this equation, like n1 plus n2 has to be greater than equal to m, then n2 has to be greater than equal to m minus n. So this also says that n2 is equal to max of 0 comma max of 0 comma m minus n, because what can happen is like this n1 can already be greater than equal to my m. So for this I take this n2 to be max of 0 of m minus n. So this can be just implemented by following the GCD procedure that I showed you. Like this GCD takes care of the negative powers. Like we do not need to care about the negative powers. So taking GCD just takes the minimum power that is present, like it takes the minimum of n1 comma m1, minimum of n2 comma m2, minimum of n3 comma m3. So if I divide this by this, what I get is p1 into n1 minus minimum of n1 comma m1. So this will give me the corresponding power of prime that should be present in my number y. So like the the same procedure will be done for each of the prime numbers. So if I just divide A into B by GCD of A into B and X, what I get is the minimum possible Y that should be present such that each of the corresponding powers, like n1 plus n2 should be greater than equal to m. So this gives me the minimum possible n2 that should be present in my number y. So what I do is basically for each of the numbers, that is I iterate for my x to be a plus 1 and it goes till c, and for each of that I'll calculate the GCD of A into B and my corresponding X. And to find the minimum B, what I do is I divide this A into B by the GCD, and I check whether the number that I got already lies in the given range or not. If it lies in the given range, I just print my corresponding value of X and my corresponding value of Y, and I return. Otherwise, I find the minimum multiple of this number B that is just greater than equal to my B plus 1. So how do I calculate this? I find the quotient of this and I multiply the number by the quotient, and I check the final thing that we got after performing this operation is less than equal to D. Like the next multiple of number B, like the next multiple of number Y that I get, like the next like the next multiple of number Y that is just greater than equal to B plus 1 has to be less than equal to D. So if this condition is satisfied, like the number Y lies in the given range, so in that case I print my number X and my number Y that I perform after taking it to the next multiple that is just greater than equal to B plus 1. So if this is valid, then I print my final answer. Otherwise, I return -1 and -1. So this is the solution for problem E. Thank you for watching.